Hi guys, welcome to this tutorial for blood type genetics worksheet. I'm going to do this video in two sections so that it's a little easier to find specific problems. So this first video is going to be just the front page, and then I'll create a second one for the back page. Okay, so we have some information up in this corner to give you the genotypes of these different blood types. You can also find all this information in your notes. Maybe a good cross-reference will be to make sure that the information here matches up with the information in your notes. That way you won't be led astray if you're studying from your notes. Okay, here we go. So let's read through number one. So we have two parents. One has type A blood, one has type AB blood. We want to know all possible genotypes of the parents and offspring. List all possible phenotypes the children could have, and we have two Punnett squares set up for you. Alright, so let's first work on these genotypes of the parents. Okay, so type A blood, let's take a look at the possibilities up here. We have two options, either capital IA, lowercase I, or IA. Okay, so two options there. Type AB, only one possibility right here. So capital IA, capital IB. Alright, so this makes sense because we only have two Punnett squares to work with. So both Punnett squares are going to be having a parent with this genotype. Let's fill that in here. Let's put that on the top because that's the same. And it doesn't matter whether you put it on the top or the bottom, but just to be consistent, I'll put it here. Okay. And remember, we have these two options here for the other parent's genotype. So we have to represent those both on these separate Punnett squares. So let's take this one and put it in here, capital IA, lowercase I. And we'll take this one and swing it around here, capital IA, capital IA. Great. So let's go ahead and cross these, and if you are done with this, or if you already feel good about your ability to cross, you can go ahead and fast forward through this. But if you're still figuring this out, feel free to watch the whole way through. Okay, and over here, again, just to be very deliberate, I'm bringing this one down to both of these. I'm bringing these both across. So that one comes from there. The B comes from up top. Okay, we've got all of our crosses finished. So what we're looking for now, according to the question, is the possible genotypes for the parents. We have that already, but what about the offspring? Let's list our possible genotypes. So here I've got homozygous dominant for A. That's that one. I've got, let's see here. I've got AB. I've got A type blood, but heterozygous. I've got B type blood, heterozygous. Wow, all four different genotypes. You can see how these multiple alleles can get a little more complicated than a typical monohybrid cross. Not so bad over here though. These two match up, so that's one. and these two match up, so that's 2. So only 2 options over here. Fortunately, these boil down a little bit for our phenotypes. So let's decipher all the possible phenotypes from this list here. So this one here is going to result in an A blood type, as is this one down here. Even though it's a different genotype, it still is just A. So we can get rid of that, get rid of that. This one here is going to result in a B blood type. That's good. And then this one here, because this is a multiple allele trait, we have both A and B. So that's going to result in AB. All right, moving on. Here, this is going to be A, because all A alleles. This is going to be AB. Okay, that's that. So a lot of information there, but if you take it one step at a time, it's not too bad. All right, moving on to the second problem here. We've got a mystery to solve. So we have a young woman who mothered a child, and she is accusing a certain soldier, a male soldier, of being the father of that child, which he denies. So the soldier's lawyer demanded the blood type be taken to prove the innocence of this client. Following results were obtained. So the alleged father took a test, and they determined he was blood type O. The mother took the test, and she's blood type A. And the child took the test, determined the child was AB. Okay, so some of you might immediately kind of realize what the outcome is, but let's go through this step by step. So the court, and this is a twist to the story, the court found the soldier guilty on the basis of her remarkable memory for dates and details that apparently eliminated all other possible fathers. So let's be a forensic scientist for a second and study this and see what the outcome is. So what are the possible genotypes for all 3 people? So let's start with the parents. So first, father. For type O blood, that is exhibiting neither of the dominant alleles. And again, you can scroll back up here and look at the key. You can see the genotype is listed right there. So let's fill that in. Lowercase I, lowercase I. The mother, is type A. So she could be one or the other of these. So let's write both of those down because we don't know. So we can't assume. Or IA, IA. Okay, scroll back up here. Now, the child is type AB. So the child has only one option as well. Again, look, we did this in our last problem. The only genotype that can result in AB is IA, IB. So, we have a decision to make. Do we agree with the court's decision? Well, let's tear this apart real quick. So, it's pretty obvious that the IA allele came from the mother. So that one is taken care of, right? It doesn't matter what genotype she was. We know for sure she had at least one of these alleles to contribute. And we know the child doesn't have any lowercase, so that one doesn't matter either. The father only has lowercase recessive alleles. The child has none of those. So that's one reason we can eliminate this guy as being the father. A secondary reason is the child needs to have gotten this B, capital IB, from somebody, which this man does not have to contribute. So this man cannot be this child's father because it does not have a lowercase I. So I would say no. And on the basis of the father does not have a capital IB allele to contribute, and he would need that allele to be the father. Okay, mystery solved. Unfortunately, the court didn't agree. So you'd have to bring this evidence, probably the lawyer would have to bring this evidence and overturn the ruling. Okay, last problem on this page, and then I'll flip to the second clip. So we want to know, and when I assign this in class, I will have already told you, I want to know the phenotypic ratio here. So we'll all correct that when I assign this to you. By the time you watch this, you'll have already heard that information. Okay, so phenotypic ratio for the following couple. So this is, as you can see, a 2-trait genotype. So we're going to have to do a dihybrid cross. All right. There will be less possibilities by looking for the phenotypic ratio, but there is still a few steps involved. I am going to use the shortcut method. If you want to use the full-size Punnett square, that's fine, but I find this method a little faster. Okay, so I need 2 Punnett squares, one for the I alleles, one for the R alleles. So let's fill in the parents, IA, IB, and lowercase I, lowercase I. And then over here, both parents are heterozygous. Okay, cross it up. Oops, that's supposed to be an I, sorry guys. Okay. Okay, now remember, we're just looking for the phenotypic ratio, so we can simplify this slightly. Let's look here. So here we have type A, type A, type B, type B. So we only have 2 things, half and half, 2 out of 4, 2 out of 4. So I'm going to spare you all the math, but it's going to end up being half and half. So here I'm going to write half of them are going to be type A, and give yourself plenty of space here. Half of them are going to be type B blood. Okay, let's look over here. We've got, remember, we're only looking for phenotype. So, and this is a binary trait, a Mendelian trait. So 1, 2, 3 contain a dominant allele. So those all are going to be positive. Only this guy down here is going to be negative. All right. So we need to now combine these. We've only done this in class once, so I'll go slow. So out of the half that are type A, we have an opportunity to have 3/4 of them be positive. We have an opportunity for 1/4 of them to be negative. Okay, so let's do the math on this one. 1/2 times 3/4 results in 3/8. A positive. Again, 1/2 times 1/4, 1/8 chance of being A negative. Okay, same deal down here, and the math is the same. So 3/4 positive, 1/4 negative, using the same Punnett square. So we're going to get the same results, 3/8, but this time it's B positive. And here we've got B negative for 1/8. Okay, so if you had counted up the squares in a 16 square Punnett square, you would have ended up with 6/16, 2/16, 6/16, 2/16, and you could have simplified to these exact same ratios. All right, but this is our phenotypic ratio for this problem. Okay, I'm going to stop here, and you can pick up on the back page in the second video.